Okay, and here we are, chapter 7.3, the unit circle. This is pages 2 and 3 because they go together. So on page 1, we talked about our first special right triangle and isosceles right triangle. That means that two sides are the same length, which also means that the angles opposite them are the same size. So if we've got one right angle that's 90 and our other 90 degrees is split between two angles, they've got to be 45 degrees each. So sometimes this is called a 45-45-90 triangle. So just to be aware of that in the event that you see that in the notes or the homework. So our second special right triangle, it's our last one, is a 30-60-90. And we are going to build this by taking an equilateral triangle. Equilateral means all three sides are the same length. So equilateral triangle. And I can write this and give you a chance to read ahead a little. So we have our equilateral triangle. Every side has length 2s. Okay, so I've got 2s right here, 2s right here. I'm dropping that altitude, which we're calling h, in that equilateral triangle. It cuts the other side in half. So here's our 2s, s plus s. Makes a 90-degree angle. We know that if the triangle is equilateral, it's also equiangular, which means all three angles are the same. So we divide 180 by 3, and we get this 60 degrees for each angle. When we drop that altitude down, it cuts that 60 degrees in half, and we have two 30-degree angles at the top. So we are looking at just one of these triangles. Okay, we've got a 30-degree angle, we've got a 90-degree angle, we've got a 60-degree angle. And then we've got our sides labeled H, S, and 2S. And we don't necessarily like having the two different variables, but we can definitely solve for one side in terms of the other. So we're going to go back to the Pythagorean theorem, just like we did with the first special right triangle. So here are the lengths of our legs. We've got s squared plus h squared equals 2s squared. Remember that 2s squared means 2s times 2s. So I'm going to go this way. S squared plus h squared equals 4s squared. And subtract the s squared from both sides. I get h squared equals 3s squared. And then we're going to go ahead and do what we did to solve for h on the last one. We're going to solve in terms of s, and we're going to square root both sides. And we get h equals the square root of 3 times s. Remember, s was the length of the side in our triangle, the length of the short side, actually. And so some neat things happen here. If I have one side, the short side, I know I multiply by square root of 3 to get the long leg. And I multiply that short side by 2 to get the hypotenuse. Okay? So let's fill that in here. From this, we can conclude that the length of the longer leg is the length of the short leg multiplied by square root of 3. Okay. Just like the isosceles right triangle, we only need one side in order to determine the other two in a 30-60-90 triangle. The ratio of the three sides is written x, that's the shortest side, square root of 3 times x, that's the longer leg, so I shouldn't say short side, short leg, long leg, 2x, hypotenuse. X is the shortest leg, square root of 3 times x is the long leg, and 2x is the hypotenuse. Okay, you guys, one thing at the bottom here that's really important to remember as we move forward working with triangles, shortest side is always opposite the smallest angle. The longest side is always opposite the largest angle, which in this triangle is going to be a 90-degree angle. Okay, and so you can match up, or as you're working through stuff, you want to make sure that you're getting answers that are making sense in terms of what you have. On to page 3. So let's find the missing sides. It looks like the directions are at the bottom of page 2. It says find the lengths of the two missing sides in the 30, 60, 90 triangles. So here we have the longer leg. To get to shorter leg, we're going to divide by, didn't mean to do that. We're going to divide by the square root of 3. And so we get 4 square roots of 3 over the square root of 3. And x is 4. Okay. The hypotenuse is 2 times the short leg. So times 2 for the hypotenuse. 4 times 2 is 8. Okay. For B, we have the length of the hypotenuse. We can look at our triangle, make sure we're setting things up correctly. They're always not drawn the way we want them to be. If we have a 60-degree given, that means our other angle is our 30-degree angle, which means y is our short side. Our short side is always opposite the smallest angle. So to get from the hypotenuse, let's see if we can go with the same color, to the short side, we're going to divide by 2. And here's a place where I'm going to leave it as an improper fraction, 17 over 2. Because as I multiply further, it's just going to make it a little easier. 17 over 2. Let's make it a little more legible. To get from the short side to the short leg, to the long leg, we're going to multiply by square root of 3. And we get 17 square roots of 3. Remember that radical can just go in the numerator over 2. Oh, why won't let me make a multiplication? Okay, so C, same thing. Right? We've got the long leg. It's opposite the 60. Here's our 30-degree angle, so y again is our short leg. We are going to get from the long leg to the short leg by dividing by square root of 3. So I'm just going to write it that way, 15 divided by the square root of 3. And then we're going to go ahead and do what we did before. We don't like having that radical 3 in the denominator, so I want to rationalize that denominator. Square root of 3 over square root of 3 is being multiplied. I get 15 square roots of 3 over 3. I can cancel the 3 in the 15, and we end up with 5 square roots of 3. There's our short side. To get to our long side, again, we just multiply that short side by 2. The 2 multiplies by the whole number part on the outside, that 10. Does not multiply inside that radical. So we've got 10 square roots of 3 for the hypotenuse. Last one, D. This time we're given the hypotenuse. That is a cross from the right angle, so we know that's our hypotenuse. So we find the short leg by dividing by 2. So I've got 24 square roots of 21 over 2, which makes y equal 12 times the square root of 21. To go from the short leg to the long leg, we multiply by the square root of 3. So I'm going to do that over here. X equals, I've got 12 square roots of 21 times the square root of 3. And because I'd rather not divide this and make it bigger, I'm going to go ahead and rewrite 21 as 7 times 3. And then I'm going to multiply it in my other 3. Okay, because we can multiply underneath those radical signs. We get 12 times the square root of 7 times the square root of 9, a couple extra steps. We know that we can multiply in any order, and now let me go ahead and fill that in. We know that the square root of 9 is 3. We multiply that and we get 36 square roots of 7. 36 square roots of 7. And we've got all three sides. You guys, this is not a main focus of this section. This will help as we build the unit circle though. A couple of things that might help you remember it. 45, 45, 90, we have two sides that are the same length. We've got that square root of 2 in there. The ratio is x to x square roots of 2, leg to hypotenuse. And for our 30, 60, 90, we've got three different angles, three different sides, three different length sides. The ratio is x to x square roots of 3 to 2x, and we are going in order from smallest to largest.